Okay, so yes, today we are talking about potential and kinetic energy. Yesterday, we talked about different types of energy like chemical energy, sound energy, electrical energy. There was elastic energy, okay? Those that we learned about yesterday fit into these two categories, okay? And we'll talk about that in more detail on the back page of our notes. This front page of our notes is just pretty simple information. It's a shallow side of our notes. The back side, we get a little bit deeper, okay? So, somebody tell me, think back to when you learned about this. I think it was in 8th grade. What is potential energy?
Is it energy that's like stored?
Yeah, good job. Energy that is stored. Okay, it's stored for later use. All right, whenever it gets used, it kind of switches over to kinetic energy, which is what you would say. What's kinetic energy?
Energy that is released.
That is what?
Well, like
Yes, but
Involves moving, accelerating.
it involves motion. Okay, so kinetic energy is energy that involves motion. Okay, so whenever you see something moving, that is kinetic energy. All right? So what we're going to do is we're going to work our way through the rest of this note sheet and identify examples of potential energy and kinetic energy in different pictures we have going on. Okay? The first area that we're going to go to is this top right picture. Okay, we have this girl holding a ball and it shows that she drops it. Okay? So let's fill out this square first. All energy can be classified as two types. What are those two types?
Potential and kinetic.
Potential and kinetic. Time to go buy more markers.
Missy, where's my directions?
Yes. You just walked in front of my video, bro. How rude.
Well, everyone.
Okay. She's holding the ball. Okay, nothing's really going on. What type of energy does that ball have whenever she's holding it right here? Potential. Okay, it has the potential to start moving, but it's not right now. Okay, she drops the ball is now moving. Now what kind of energy? Kinetic. Okay, if you want to shorthand this to K dot E dot for kinetic energy, you can. You will find that I do that a lot because what's the point in writing it all out, right? We're lazy, so let's shorthand everything. Okay, is everybody good in that top right square?
Yes.
Okay, like I said, this first side is pretty self-explanatory, not a whole lot of depth happening. Okay, now I want to talk about this roller coaster that we have going through the middle of our page. Okay, we have a dude at the top of the roller coaster. His shirt says potential. Okay, keep that in mind. He goes down the roller coaster, and now his shirt says kinetic.
So it was so fast that it changed.
Yes, potential energy and kinetic energy are kind of always in a relationship with each other. If potential energy goes down, kinetic energy goes up. If kinetic energy goes down, potential energy goes up. Okay, they kind of work back and forth like that. When Isaac is at the top of the hill, he has the most
Kinetic or potential.
potential. Yes, I'm going to put P dot E dot. Potential energy. As Isaac travels down the hill, potential energy changes into kinetic energy. Yes. K dot E dot. These markers are literally garbage. So is my shot.
Did you make it?
No.
Oh, well then.
Okay, so a roller coaster has a lot of potential energy at the top. As we move down a ramp on the roller coaster, we convert it into kinetic energy, the energy of motion. Okay, this bottom section, the last section on the front page, is just different examples, and we're going to identify which part of that example is potential and which part is kinetic. Okay, so let's start with this hammer right here. Okay, so we have two situations on the hammer. Which one, this top one or this bottom square, would be potential?
top one.
The top one, okay? So that's you holding the hammer above the nail, all right? When you slam the hammer down like this right here, what kind of energy is that?
Kinetic.
Kinetic, okay? So this first one is potential energy, and then as you swing the hammer, it converts into kinetic energy. Okay? This example on the bottom left, we have filled up a balloon, okay? We're holding it. And then we let it go, and the balloon goes crazy because all that air escapes. All right? Whenever all the air escapes and the balloon goes crazy, what type of energy is that?
The kinetic.
The
is
kinetic
air.
energy. Okay, so this one down here is kinetic energy. Whenever we release that air and the balloon moves like a wild man. And what type of energy do we have when we just have the balloon? We're not letting it go yet. Potential.
Does it lose energy when it goes to kinetic, or does it gain?
No. Oh, the marker just fell out.
And then lose.
It converts, so it's the same amount of energy. It's just now it's kinetic instead of potential.
Doesn't it slowly lose energy though?
Nope, it's the same amount of energy. Energy is conserved.
What about
What about what?
a balloon? So say that the air is kinetic energy. And you let the balloon go. But
Well,
it's-
you can't see the air particles. They have all that energy. Okay, we have two situations here with this tree. We have a person swinging, and we have a leaf falling out of the tree. Okay, let's talk about the leaf first.
Oh, I thought the tree was breaking. He was gonna fall.
It's just a leaf. Whenever this leaf is falling, what type of energy does it have?
Kinetic.
Kinetic energy, Ke. When the leaf is still attached to the tree, what type of energy does it have?
Potential.
Potential energy. Alright, person swinging. Okay, think about, it might have been a long time since you have swung. But whenever you go back, there's like that half second where you feel like you're hanging and then you come back down. Okay, yes, at the top of your swing, you have potential energy. Mid-swing, you have kinetic energy. Do y'all think y'all can, like if you were to give them this front page, you could do that by yourself? Okay, good. Awesome. Let's go ahead and turn to the other pages. So this one, what I'm about to show you, is already filled out for you. So what we're going to do is you're going to write the information down, and then I'm going to talk about it. Sound like a plan?
Wait, why is it
Can we explain it?
upside down? Sounds like upside down.
Yeah, I know. Okay, here's potential. I want y'all to write that information down, and then I'm going to talk about it. Okay, pause. This says student-generated response. Do not write that. Leave that blank. Okay, we will talk about this. Where'd he go?
I can't even read that.
Maybe if you were at your desk, you could.
Wave to our viewers. Oh. Make sure you get everything for me, please.
How come our paper's upside down?
Don't worry about it.
Oh, we're not supposed to worry about that?
In case you missed it, in this top left corner, there's stored energy up here. Okay, this red. Don't forget to write that down as well. Okay, so like I said, you keep writing, I'm just going to start talking. This half of our notes goes into much greater detail. Okay, we know that potential energy is stored energy. We talked about that on the first page. But now we go in a little bit more detail. Stored in an object due to its position or composition. So position at what height it is at. We'll talk about that later. Or composition, so what's it made out of also determines potential energy. Okay? Now, out of the ones we learned about yesterday, chemical, elastic, and gravitational energy are types of potential energy. Okay? So those go under potential. Alright? Potential is the main idea. These three fit under that main idea. Okay? These were explained in our notes yesterday. Chemical energy, energy released or absorbed during a chemical reaction. Foods provide us or have chemical energy. Okay? Our bodies transform that into nutrition so that we can function. Okay? We have elastic energy. So think about a trampoline. Think about springs. Rubber bands have elastic energy. Okay? And we have gravitational energy. There's something that I want to add to this after y'all are done writing. Okay, we're going to kind of expand on that. Energy of an object due to its height or position. Let me add a text box here. Whoa. More height equals more potential energy. Okay, add this text box that I just put on there.
So would those three types of energy still be considered their own, or what? Or is that
Yes, but they're under potential. Okay, so let me talk about this gravitational energy and what I wrote here. More height equals more potential energy. Okay, so if this ball is sitting still on top of this hill, okay, it has potential energy on top of the hill. It rolls and it now rests at the bottom of the hill where it has potential energy again, okay, because it's sitting still. It has more potential energy at the top than it does at the bottom because it's at a taller height. Okay, so the tallest point of potential energy is the most potential energy. Okay, so if a roller coaster has a big loop and then a small loop, the top of them, this one has more potential energy than this one because it's taller. Okay, that's what I mean by that.
So basically it loses energy.
No, it's converted into kinetic energy.
But you said it.
You're going to see a video in a second and it'll explain it. I promise. Okay, this right here, our example for potential energy, we're going to calculate some stuff tomorrow. We're not going to do any math today, okay? But this is just showing you to find potential energy, you're going to multiply mass, gravity, and height. Okay, you multiply all three of those together and you get your total potential energy. Okay? Does anybody remember from yesterday what is energy measured in? What's the unit for energy?
MC?
Joules, okay, capital J. Okay, here's my example of potential energy sitting at the top of a roller coaster. Okay, you have potential. Somebody tell me an example that we can write right here. What's an example of potential energy? Somebody give me something. A car at the top of a hill. Yes. Anybody else? That's already drawn. I need a different one.
A swing? Someone swinging.
Someone swinging. Yes. Okay.
Someone about to go skydive.
Yes. You can write whatever you want right here in this example. Okay? Y'all ready for kinetic?
Sure.
Alright. Kinetic goes by a lot faster. There's not as much to write. So here is our kinetic energy. I'll let y'all write and then I will expand.
So is nuclear energy the only one that's not a part of this, part of kinetic and physical?
Nuclear energy would be kinetic energy. I just didn't write them all down.
Say driving or
Driving. Okay, so we know kinetic energy is matter in motion. Okay, how do you demonstrate kinetic energy? So how do our bodies demonstrate kinetic energy? Just a few examples. Whenever we walk, talk, driving, or running, we're in motion, right? So that is our bodies in kinetic energy, or showing kinetic energy. Examples. So we learned about these 4 yesterday. Okay, sound, light, thermal energy, and electrical energy are all forms of kinetic energy. Okay, they all involve the movement of either particles, a current, something like that. We are going to calculate kinetic energy as well, all right? And that's that formula, but we're going to wait a couple days before we get into that. Today, I just wanted to show you the formula. We're not actually going to use it yet. Okay, I have like a 3-minute video I want to show you guys. And in the middle of it, it shows that relationship I'm talking about between potential and kinetic energy. Okay, and hopefully it makes a little bit more sense to you guys whenever you see it. I think they do a good job of showing it. Is everybody good here? Okay, let's look at this video really quick.
With their high speeds and bright colors, you may find it hard to believe that roller coasters have been around for more than 200 years. But since their beginning, the basic science behind roller coasters has remained the same. It's the science of forces, energy, and motion, called physics. Like any other amusement park ride, roller coasters need energy to work. But it's what happens to that energy that makes roller coasters unique. First, the cars of a roller coaster are pulled to the top of a steep slope by either a chain system or another machine for pulling and lifting, called a winch. These machines need energy to work, but this energy doesn't just disappear. It is changed and given to the cars of the roller coaster. What is this energy changed into, and how does it go from the winch to the cars? An object sitting still at the top of a hill has stored energy due to its position. This position gives it the chance or potential to move down the hill, and so we call this stored energy potential energy. As the cars of a roller coaster are pulled up to their starting position, they are gaining potential energy. The higher the cars are pulled, the more potential energy they gain. And once there's enough potential energy, the fun begins. As the coaster cars zoom down the track, their potential energy is turned into another kind of energy. If potential energy is the energy of position, what do we call the energy of motion? Kinetic energy. Both this potential and kinetic energy rely on a fundamental force of the universe, the force of attraction between all things that we here on Earth feel most strongly as the downward pull of gravity. When roller coaster cars go
here it
over
is.
the top of the ride's first hill,
So this is
force of
showing
gravity
you
pulls them downwards, turning their
their
potential
relationship.
energy into kinetic energy.
It'll keep changing.
And as the cars climb the next hill, the kinetic energy is turned back into potential energy, which is then released again as kinetic energy, and so on.
Okay, so that's a good picture of the relationship
Alternating
between them.
these two types of energy makes for an exhilarating ride. Now the next time you ride on or see a roller coaster, whether just going up and down hills or spiraling through turns at 60 miles an hour, you'll know a little more about how physics is turned into fun.
Okay, so that little section right here.
Let's go over the top of the ride's first hill.
So right now we have all the potential energy. As it goes down the hill, we move towards more kinetic, but we still have a little bit of potential.
And as the cars climb the next hill,
When it goes up a
kinetic
hill,
energy is
so it
turned
can
back
have
into
both at the
potential
same
energy,
time.
which is then released again as kinetic energy, and so on.
Okay, I think that does a really good job of explaining it. Now, what I need you to do is 9.2 assignment. Okay, it's on Canvas. It's 20 questions, but they're really straightforward. It's not a whole lot going on. Okay, you're using your notes to do 9.2 assignment. Okay, you get 3 attempts on the assignment. So if you want to do it all 3 times to get a better grade each time, go for it. Sound good?